map underscore merge function. How basically this function can be used, right? Map underscore merge function is very useful when you have to achieve parallelism. Okay, to achieve the parallelism, it is very useful. What kind of parallelism we can achieve, right? So let's suppose you have for example, you have a purchase order, right? Let's suppose you have the 10 purchase order, and for this 10 purchase order you want to get, right, you want to get the purchase order item, right? For the 10 purchase order you want 336. Let's suppose you have the 6 purchase order. Okay, for the 6 purchase order you want to get the purchase order item, PO item you want, right? So in ABAP, what we do, in ABAP we can first get the 6 purchase order based upon, let's suppose, some condition. Okay, or just get any 6 purchase order, select EBELN up to 6 rows from EKKO, right, and put into some table, at the rate data IT underscore PO, and this is your purchase order header, IT underscore PO underscore H. Now you have to get the purchase order item. So we can use the for all entries, right? So select EBELN, EBELP, and you have, let's suppose, material, right? Matter from EKPO for all entries into table. We can also write into table at the data IT underscore PO underscore I for all entries in IT underscore PO underscore H. This one. Okay. So we are using for all entries in order to get the related purchase order item, where ELN equals to IT underscore PO underscore, right? So this is how we do in ABAP, right? Now, or you can use the inner join, anything is fine. This is like based upon our requirement, but you know that we use a lot of for all entries in our ABAP in the different scenario. So if you have such kind of scenario where for a single header you have thousands of items, okay, here for a single order you don't have much items, right? Single order, you will be having 5, 6, or maybe 10 items, right? Not more than 10 or 20 items, right? So in this case, maybe this map underscore merge function is not going to be much useful, and really it's not very much useful, but just I wanted to let you know the concept. What is the concept over here? That, see, here if you are going to do the processing, it is going to be there in the sequential format, right? For one header it will get the item, it will put, for another header it will get the item, it will put, for again another header it will get the item, and it will put into this internal table, right? But using the map underscore merge function, what you can do, for one purchase order you can get the PO items in one thread, because in HANA it can have the multiple processor. So one processor you can assign to get for one purchase order the PO items, another purchase order header can be assigned to another processor to get the PO items, right? Again, another processor can be get the third processor can be assigned, right? So if you have the multiple processor, you can use those processor to achieve the parallelization. But this is mostly going to be useful for one header if you have the multiple items. In this particular scenario, you it might not be useful, but let's suppose if you have the business partner, right? For one business partner, there can be multiple sales order header, right? Maybe more than thousands or more than 10,000s, right? So if you, if instead of 6 purchase order, if you are going to put it over here, the business partner, that means the customer, one customer can have many sales orders, right? More than 100, more than right, more than 100, more than 200, more than 300, like 1,000, right? So if it is having, let's suppose, the 1,000 plus uh sales order, all right, you have the big customer. Okay, so here again you have the 1,000 plus sales order, right? So you want to get for all the business partner, you want to get the complete sales order, right? So in this kind of scenario where the item data are much more, you know, this technique is going to be very useful. In less number of records, it will not give you the better result. The reason behind that, because it has to combine the result at last also. So if you have a small number of records to get parallelly, better go sequentially. That may give you the better performance. Again, you can check it by applying which one is giving you the better performance. What I'm telling you, it is my observation. Okay, I will show you. Let's go and check it out. Map underscore merge functions. Already I have created one program. Let me uh, go and show that program first. So go into come here, and the program name I don't remember, but here it will be there. Let's this one, Z ABAP AMDP performance. Okay, using the map merge. Using the map merge, you can have the better performance. Again, it depends. It will not give you always better performance. If you have the perfect, like if you have the required condition to achieve, you will get the better performance. I will show you with the help of this example over here. See what I'm trying to do. Let me first show you this part. What I did that, first I got the header record from this table, because here we have a lot of data, right? And we got the header record, and corresponding to header record, we are getting the item records using the for all entries. And I'm trying to find out how much time it's going to take. Okay, so just some error is there. Let's see what kind of error. Check the syntax. LV score E is unknown. Get runtime field, get runtime field. Just uncomment this one, check the syntax once again, activate this. So here, see, let me comment this one. So this is the beginning time, right? I'm measuring the beginning time, and this is the end time. And this time, end time, I'm subtracting from the end time, I'm subtracting the start time. So it will give me the total time taken by this, right? Activate this one and press F8. So here you can see that 2402548 microseconds. That means 2 seconds, 402 milliseconds it has taken the time, right? Once again, if you run it, let's see how much time it's taking. 228, again 2 seconds around it's taking the time. The same thing if you want to achieve using the map and merge function, it will not give you the better result. Why? I will let you know. Okay, first let me show you it's not going to give you the better result. See here we have the same thing done using the map and merge function. So what we have done that we have created one function. See here, I have created one function method called procedure by database. Sorry, this is the procedure. This is, I have created one function in order to get the line items corresponding to a single header value. See, parent key is equal to iv underscore GUID. Okay, so it will take the single GUID value, means single purchase order header value, and corresponding to that it will give you the output, this function, right? You can see that return select star from this where client equals to this and parent key, right? Parent key in the SNWT SO invoice item is same as the node key of the SNWT SO invoice header, right? So it will give you the complete item detail only for the single header, this function. Okay, here next I've created one procedure where we are using the map underscore merge function. See, this is the map underscore merge function. In order to use the map underscore merge function, you have to pass the internal table for which you want to get the child data. Okay, so here you can see here invoice header table. From invoice header table I am getting the data into IT underscore header. So all the invoice header data I am getting into IT underscore header. And client we must have to handle explicitly in the AMDP, right? So that's purpose where condition everywhere you can see that I'm using the so this is how you also have to take care of client explicitly. Okay, so once we got all the header, then for each header record we have to get the item records, right? So for that map underscore merge we are using, we are passing this item underscore head, and each single node key value we are passing to that function, this function. See, call function head. Here you can see that call function head, correct? So how to call this function? We have to give the class name and then the this AMDP method function, right? So at the DB layer, the class name and this and the method name, with this name the UDF gets created, right? So basically we are calling the UDF, user defined function, right? And this is the import parameter we are passing. See, this is having one import parameter, right? If you see here, it is having one import parameter, this function call function header, iv underscore GUID, which we are using over here, iv underscore GUID in the where condition, right? So what basically it is going to do that each node key of this IT underscore head, that means each header record is coming over here, right? Each header record is coming over here. Each header record, let's suppose it is having 100, so all the 100 will be passed in one goes based upon the HANA resource availability. Let's suppose it is having the 100 cores available, right? So 100 cores available for the process, So one core will be assigned for the one purchase order header to get the corresponding items from this select query, and it will pass into et underscore value, right? Again, at the same time, for the second GUID, the data will go and it will fetch the data, and again it will come and map merge. What it will do, it will append the value into this. Again for the third, again for the fourth, parallelly, everything is happening parallelly. And if something is going to be parallel, automatically performance is going to be better, but not always, right? Why? Because let's suppose for one purchase order header, if you have just two records, so unnecessarily you are going to, initialize the core processor, right? Unnecessarily you are going to initialize the core of a processor. So 100 core of the processor initialization also will take some time, right? Again, you are getting the data and merging it over here, that will also take the time. So if for one header, if you have a small amount of items, right, it will not give you the better performance, because the extra stuff will take the more time, right? Getting the point? So in this case, in this case, in this case, if you see the performance, it will not give you the better performance. Press F8 and this one called procedure header, right? Run this and you can see that it's taking time, it's taking time, it's taking time, and taking time. See how much time it's taking. The same result it will give, but lot of time it will take. Say 2,94,000 entries it faced. Our report also faced the same thing, but it was so fast, right? It has also 2,24,000 entry only, but it is in 2 seconds itself, right? I can show you in debugger that it is also fetching the same amount of entry, 2,94,000, and it is taking around 2 seconds only. See, 2,94,000, right? So what you understood? So one thing we should understand, that always just writing the code in AMDP is not going to give the better performance. It can broke also. It will be very much expensive if we not do it carefully. Better, however, this is not the preferred approach. AMDP, we have to go at last. The very first approach is the CDS because of its reusability. Second, if it is not reusable, go for OpenSQL because your database abstraction interface is well designed, well written to optimize your query and pass to the DB layer, right? If nothing is working, then you can come and try with the AMDP, right? However, in BI or BW, it is very much helpful, right? You can, if you are from BI or BW background, this SQL script is going to be very much useful for you. Fine. Now here you see the 12 seconds it has taken. This procedure method has taken 12 seconds. So why to use? There is no benefit. The reason behind that, here, if you see that the total header record is, lot of header records, and corresponding to that header records, just 2-3 line items or 2-4-5 line items, something like that, right? See here, if you just press F6, here it underscore head, say 50,000 header records, right? And for 50,000 header records, total item records is how much? 2,94,000, right? See, 2,94,000. So almost 5 records for each header, which is very, very less. If you have around 1,000 records for each header, our procedure would have given you the better performance, right? That case also I have prepared and I will show you. See, for one business partner, we have to get the multiple items. sorry, yes, for one business partner we have to get the multiple items. This is our requirement. Okay, so already the code I have written, let me uncomment that. So let's comment this part now, and we are going to uncomment this one. So in this example, what I am doing, for each business partner, we have to fetch the total line items, right? For each business partner. So we have got business partner over here in this internal table. And then again, using for all entries, right? We are fetching the data from the SNWD underscore SO invoice item and putting into this internal table. And of course, I have to use the header table as well, so that I can compare the buyer guide with the node key of the, this SNWD underscore BPA, correct? Because the buyer guide of the sales order invoice header is same as the node key of the SNWD underscore BPA. So it is going to give me the total sales order invoice item for whatever the business partner it is there inside this site underscore header. But this is going to give you the better performance in procedure method using the map merge function if you implement. Why? Because the number of customer is small, and for each customer the number of items are lot more, so it will improve the performance in parallel. Okay, so see here, just I have pressed F8 and press F6. You can see that total 91 customers we are having. Total 91 customers we are having from SNWD underscore BPA. And for total 91 customers, if you see that the item is 2,94,000, right? So if you divide 2,94,000 divided by 91, here, like you will get lot more data, right? So you will get something you will get something 3,000 for each customer, right? Around 3,000, approximately 3,000 for each customer you will get. So that means if you have the more number of records for a header, you can achieve the better parallelism in the procedure using the map underscore merge function. So let me run it and see the time, how much time it's taking. You can see that it's taking 1.8 seconds, right? 1 seconds and 853 milliseconds. So approximately 1.8 seconds it's taking. The same thing using the map merge function. If you are going to do this part, I have written. One is the function and another is the procedure. See, why function I have written? Because see here, you can give only the function. Under the map merge function, one argument you have to pass for the header, and another argument you have to pass for the function method. It will support only the function, not the procedure or anything. That's why one function we have written in order to get the data for a single header, right? So that's why one function I have written and one procedure I have written where I can use the map underscore merge function. So this is how you have to also use the map underscore merge function. And this is really very, very helpful, map underscore merge function, in order to improve the performance, right? So this scenario where the performance we are not having the good because of lack of the environment lack of the proper scenario. This scenario is somehow better than this, and here you will see the power. Similarly, like in BA or BW scenario, there are so many different scenario because they have to deal with the long amount of data, large amount of data. This map and merge function comes very handy over there. And sometimes we as a developer also to make come across some requirement where this is going to be very useful, and that's where real power of AMDP comes into picture. Okay, so what I have done, I have selected all the BPA, business partner, and put into this internal table. Okay, and then each record from the business partner we are passing to the function, and here you can see the same select query we have written all the item related record from this table. So item dot star, right? Item is the alias for this SNWD SO invoice item. You can see that for this item is a alias. So simply after giving the name of the table, you can give the name of the alias. So you can give like this also. Both way it is supported. As also you can give, or here as also. Both way it is supported. If you don't give as, that also fine, right? So both way it is supported. So all the data from this item table, because I'm interested in those for business partner, here you can see that here for all entities is not going to support it, so we can use directly the inner join. And for each header which we are passing, of course it is having an importing parameter iv underscore node key. So for each header record we are populating the item records using this one. Okay, and now you will see that it will be having the better performance than that. Let's run it and call procedure BP. Run this one, and here it's again taking 1.8 milliseconds, and this has taken how much? This has also taken around that much only. Let me run it once again. Okay, and see here 1.4 millisecond. This time it has taken, yesterday I was running and it was giving me better, it was taking around 1 seconds, sometimes less than 1 seconds also. Okay, so it depends like how much resources are available, right? How much parallelism it can do. So let me run it once again and see. So 1.5 seconds. It is taking 1.5 seconds and it is taking 1.8 seconds. Let me run it once again. 1.8 seconds, right? 1.8 seconds. So I have run 3-4 times, right? And it is giving 1.8 seconds around, and it is giving us 1.5 seconds. And here again, we can run it once again and see. And 1.5 seconds. So little improvement you can see, but when you have to deal with a large amount of data, this is really very powerful feature, map underscore merge. Okay, very useful feature. Start using this one if you are using the AMDP and if you have to deal with the large amount of data. So in finance there is a table called ANLA, asset table, ANLC. There you can try with this map underscore merge. Okay, or I will also prepare some demo kind of stuff with the ANLA. Actually this is the demo system, and in this ANLA and ANLC there we don't have the much data, but in this system what we have the benefit, we can create humongous amount of data. So if you have this system, prepare the humongous amount of data for the SNWD underscore BPA, okay, or SNWD underscore for the item, for header and item, right? So currently 2,94,000, maybe 10 lakh you can try with. And if you are going to use BPA for that, it will again give you this one, the better performance. So maybe you will get the 3 times or 4 times more performance gain than using the simple for all entries, right? So in ANLA or NLC, asset related tables are having lot of data, right? In those scenarios, wherever you have the for all entries kind of stuff, and for one record, if you have the multiple records, maybe you can try with this map underscore merge function using the AMDP, and you now good in the AMDP stuff, so you can do that, right?